get sort of scared, like, oh my gosh, a whole different way to think about numbers. The good news is it relates to something we've done, but I want to make sure that you didn't, you know, leave the room or use the restroom and you miss that all of a sudden we're doing something new with numbers. But it's neat, and you're ready for it. And I'm excited to teach it to you. Yeah, I have a place that you can take down some notes, but I'm actually going to just do a little intro here. And so let me hopefully try to get your attention with that green spot right there. That green spot. They say, Miss Sally, that's just a point. Indeed it is. Okay, if you're having trouble seeing it because you're back sort of in the cheap seats, that's the 0.68. Hello. You can just grab it off the table there. But what if I said to you, or asked you, I guess would be a better way to put it, how else could we get to that point? How else could we get to that point besides walking 6 units to the right and walking 8 units up? How else can I get to that location without doing what you've done before? And again, what you've done before is you've walked 6 units horizontally and 8 units vertically. And we arrive at that point. A diagonal. I almost drew it correctly. How could you tell someone to walk on that diagonal? Would you just say walk, diagonally? Add something to it?
You could tell them, like, you could use the Pythagorean theorem to tell them how far it or like how long it is. And you could also do like the angle that it is at.
Oh. Okay, you mean that this diagonal line has a distance? Maybe we could call it R. I think I've seen that before. And there's an angle here? Well, of course there is. Because as you've seen me do time and time before, there's actually a triangle that goes with this point, right? Now, let's do it. Let's actually do here what Owen said. Let's actually find R. It's not hard to do. You can watch if you want, or you can write it down, but you've done it before. It's just the Pythagorean theorem, like Owen said. Nice job. Okay, that comes out to be 100. That is the square root of 100. So we get 10. How about that angle? That's a little bit more fancy. Ooh, angles. Angles. Well, you could wait for someone to tell you, or you could think about it. It's a triangle with an angle. Go ahead. Yeah, you definitely could. I kind of like SOHCAHTOA because it's a little bit more clean. It gets you there right away. Which SOHCAHTOA would it be? We're trying to find theta. We know the opposite. We know the adjacent. So it would have to be tangent. It would be tangent. All right. So the point a little more here is that you can do this.
Could you do also like sine?
Yeah, you could have, because you had your R already. Good. And again, the point here is that you can do it. You can find theta. You can find the radius. If you're doing that on your calculator, do the inverse. It comes out to around 53 if you just trust yourself. But my whole point is that you can do it.
Could you also have just said that it's a 3, 4, and then said it's a 5?
So it's a 3, 4, 5? Yeah. In fact, it is a special triangle kind of popping up again. Now, unless you have all your angles memorized in a 3, 4, 5, you still would have to probably work out theta. But it comes out to 53. Now, here's the point. No pun intended. Here's the point. You just described 6, 8 using a radius and an angle. Can you read that up there? I just wrote 10, 53. And I'm not making this up. 10, 53 is a point. But it's described with a radius and an angle. Now, if somebody tells you to go to the point 1053, it's kind of like they're telling you to rotate 53 degrees, which looks like that diagonal line, and walk out 10 units. And of course, if you do that, you end up at the same place, the same point. It's a new way to think about numbers. That's kind of what I meant by that. Okay, it's not like 2 + 2 = 5, but it's a new way to think about points. And it's called polar mathematics. Let me just put this up and I'll take your question. It's called polar mathematics. Go ahead. Technically, I'm never going to take off for that because I'll forget it too. But technically, 53 degrees is what that number, it represents a degree. Polar mathematics. It's a new way to think about numbers. What it really is a new way to describe points using, well, radii and angles. And we're going to begin like a kind of like a survey of this. When I say survey, I mean we're going to be kind of looking at the big ideas. You know, you could take a whole course on this. Right? We're just going to spend 3 weeks kind of surveying it. Okay, but you'll get a lot out of it. Actually, had a student that went to MIT. He happened to write me an email. He said, "Miss Naylor, that polar unit that you taught us, that was so helpful." And I'm not sharing that to try to toot a horn, but just we're gonna survey this. But apparently, it's pretty helpful, even so. So, and it's neat. It's new. It's different. And let's begin officially with, I'll call topic 5.1. But we're going to actually talk a little bit more here about these polar points. We're going to dig a little deeper into the idea of polar points, which we've actually scratched the surface here. So what can we say? Well, first of all, the notation of a polar point. Just to make sure that you get this, it's r and theta. It's not x and y anymore, at least not for this chapter. It's r and theta. R is a radius, a diagonal distance. Theta is an angle. Kind of obvious, but we'll just make sure we get that written. And the cool thing is that an r and a theta still gives us a point. It still gives us a location. Now, when you graph r and theta, you don't graph it on the x and y axis. You don't graph it on a Cartesian. Cartesian means x and y. You actually graph it on what's called a polar plane. You graph it on a polar plane. Now, we're also not talking about like an airplane, that's going like the North Pole or something. We're actually talking about a surface. Let's draw a polar plane. I'm going to draw it over here because I want to use it for something in a moment. But the interesting thing about the polar plane is that it's actually quite simple. It's made up of one axis. It's called the polar axis. Again, x and y axis, not anymore. It's just the polar axis. And the polar axis is basically 0 degrees. It's kind of like your reference. And not a surprise, we typically draw it out to the right, which is where 0 degrees usually goes. We also have this point in the middle, but instead of calling it the origin, we call it the pole. The pole. It's a point. It's the point in the middle. Now, what makes this kind of get a little more interesting is when we start to draw radii. And how good are you at drawing concentric circles? A compass would make this easier, but when you start to draw concentric circles around the pole, it starts to look a little bit more two-dimensional. It starts to look like a polar plane. Again, it's a place where you graph points. Mine got a little bit lopsided at the bottom, but we get the idea. I'm actually going to give you some polar graph paper for homework and also tomorrow, but it doesn't hurt to draw some of it on your own. You just get the idea that you have radii are circles, and you have a polar axis, which is 0 degrees. All right, let's sort of take this up to the next level. And let's plot a polar point, like from scratch. Let's plot 2, 120. Maybe you can think back to, and some of you were just doing this a moment ago, back to 6th grade or so when you first graphed something x and y. You know, ooh, you graphed x and y. Now we're going to graph r and theta. And it's not hard, but let's think about it carefully the first time. You actually want to rotate first. You want to rotate to 120. Obviously, I'm just kind of estimating that, but I would rotate to 120, and then I would move out 2 radii. And voila, we get the point 2, 120. Now, that's not bad. But what if I told you, or sort of asked you, could you think of another way to get to that point? Wait, you mean like a different set of numbers, but takes us to the same place? Yeah. So another way to get to that point. What about if I rotated? What about if I rotated? Is that right? Negative 240? Yes, I believe it is. We should all be able to say, if we think about it, that negative 240 is still the same angle. It's still at the same place. Okay, now let's make sure that we can say this. There's some things that are usually helpful for kids, especially when we start doing this. It's usually helpful to kind of divide up your plane a little bit, right? Like with the 4 corners. I know you know this, but it's just helpful to think about this. This would be negative, or this would be 90. It would also be negative 270, now that we get this negative going on. Of course, this is 180 or negative 180. And then down here is 270 or negative 90. Again, it doesn't hurt just to bring those numbers back into your mind. But yeah, I think, Owen, you've got that exactly right, that is negative 240. This pink reference angle, something you've seen before, can also be helpful when having this conversation. So maybe the number 60 or the angle of 60 is kind of front and center. Wait, there's another way? Well, actually, there's 2 more ways for a total of 4. Say, what? How else could I rotate to that point? This one is probably going to require a little teacher input. So I want you to think with me for a moment about being on the opposite side. Now, if there's anything that's a little tricky today, it's this right now. I want to try to explain it carefully, but try to also listen. First of all, I'm on the opposite side of where I want to be. Since I'm on the opposite side of where I want to be, I can't use a positive radius. Okay, because if I would rotate to this side, let's rotate to this angle. We need to get like a number here. How's that going? Let's just get a rotation. I think if we rotate around, do a little thinking about 60, you're at 300, right? 300. So here's the thing. If I rotate to 300, listen to this carefully. If I rotate to 300, I am not going to be at the point. So since I rotated over here to this side, I need to use an opposite radius. I need to use a -2 so that, and this is maybe the part you just want to watch, so that I don't stay at 300. Because when I see this opposite sign, it actually makes me do this. It makes me go to the opposite side. And when I go to the opposite side of where I was, I'm back to the same point. Okay, so this -2 tells me to go to the opposite side, which again is back to the same place. There's one more way to get to the opposite side. 300, and of course, -60. Listen to this carefully. If I go to -60, I'm on the opposite side. So I need to use a -2 to take me back over to the point. What I have found that kids get confused, and I hope it's not the way I'm saying it, but sometimes kids get confused that they think that these 2 points right here are actually over here. Okay, these 2 points, here's kind of the sort of blows you away a little bit. These 2 points are actually this same point. All 4 of those are the same point. Okay, I'm just on the opposite side, so I use a negative sign or an opposite sign to go back over here. Let's try another one. Now that we've opened up this little can of worms, you will find out that there's always 4 ways to write a polar point. There's always 4 ways. I'm going to start with one of these opposite points because, well, I really want to make sure you understand how to graph -3, 220. If you want to use the same graph paper, if you want to draw a new one, give you a second to decide what you want to do there. But again, I really want you to understand how to graph -3, 220. And if there's anything that's sometimes a little tricky, it's this. It sometimes confuses kids, and I don't want to be that point of confusion. Listen, you're going to rotate to 220. That is a guarantee. So you can kind of think about that. You can draw a line. I'm going to draw it as a dotted line. The reason I'm drawing it as a dotted line is because as I look at the point, I see that I'm actually on the opposite side of where I want to be. So 220, yes, it's right there. But since I'm on the opposite side, I will eventually need to transfer over there. I will have to transfer over here. And I will go 3 units. And voila, I'm at the point. So please understand that that point right there is known as -3, 220. That is correct. There has to be a point here where we start to think about some reference angles. As Owen said here, 40 degrees becomes the reference. It becomes what we're going to think about. Of course, a little geometry transfers it over there. And maybe you're already thinking about some more ways to do this problem. In fact, the easiest way to describe it is with a straight up 40 and a straight up 3. Does a 3 and a 40 take me to that point right away? What's another way to get to this point? Sometimes students miss this one because they're so concerned about all this opposite stuff. But the other way to get to this point is just to rotate negatively. Now, if I rotate negatively, I'm still going to this point. I'm just rotating all the way around -320, -320. But it's still going to be a +3 because I'm on the side. I'm on the original side. It's this opposite side that we want to think about rotating one more manner. And if I rotate to the opposite side, I have to use a -3, but I can rotate negatively to this opposite side. I think that's going to be what, -140? Make sure you get this. -3, -140. is still that point. Because I would rotate to negative 140, I'd be on the dotted line, but negative 3 tells me to go back over, or tells me to go to the opposite side, which is actually back to the original point. Try one. Hold on, before we try one, are you noticing a little something? Are you noticing a little something about the types of answers we get? I'm talking about like plus and minus. What are you noticing?
Like they go very simple.
What's they? Who's they?
Like the negative there, it doesn't look the positive side.
Okay, so that is definitely true. Wait, not that one, right? Is that what you're referring to? Okay, and of course, as she said, we're kind of using a little bit of sort of absolute value, but that looks like that adds up to 360. Listen, that is true, but as your math teacher, I'm not going to like make a big deal out of that, because if I find that kids forget what that is. It's like, what does that mean? It's something you can notice. It's something that might help you check your answers, but I'm not going to teach it like a formula or some type of shortcut, and then we forget what it means to graph the point. And I just know that you need to be able to graph these points without shortcuts like that. But it is true, okay? That's why we brought it up. It's also true that you're always going to get a plus plus. You're always going to get a plus minus. You're always going to get a minus plus. And you're always going to get a minus minus. And I like that because that reminds me of the original text message or emoji or whatever those little things are. This is like it's like, if you put that at the end of your message, I don't know, what's this? Is this like somebody winking? All right. I just heard on the news today that the first text message was sent back in 1992. So I don't know, it's just random trivia. Maybe they put it probably took a while though for people to figure this out. All right. Try one. And when I say try it, just quite honestly, whatever you want to do. Are you gonna, you need to graph it. I want you to graph it. But are you going to use some patterns? I'm just going to be quiet and what have you picked up on? Can you graph it and can you name it? You want to name it 3 more ways. -4, -315. -4, -315.
I'm confused. What to do with the number and in the first place at the 3?
Tell me the number.
Like the first value and that.
So for this one, is it the -4?
Yeah.
Okay, that's a good question. Actually, you don't do anything with it. You actually want to start with the second number. You actually want to rotate first.
Okay. So will I do anything at all with the -4?
You will move. Once you rotate, you will move in the opposite direction 4 units.
Okay.
Try to rotate first, and then you can think about the opposite direction. Yeah, usually I don't have those memorized. Yeah, good, not negative.
When I was going up through
Just put a plus put a slash through them, make them plus. I notice people kind of come up with their own little system to do this. That's why I'm just giving you a chance to do it, but make sure you understand that that's the point. Now, it's important. Don't feel bad if you're a little confused by this. I rotated to negative 315, but because it says negative 4, I don't stay there. I don't put a point out here. I go to the opposite side. So I go vroom to the opposite side of this line, and that's my point. That's the place. There's other numbers that come into play here. 45 degrees becomes a helpful number. Okay, looks good. All this is just affirming the kind of thinking you guys are doing. Which one did you want to do next? I mean, it doesn't really matter. Some people go back to the positive. What's a positive way to rotate here? That'd be 225. Sometimes people forget about the other positive. The other positive is the just rotating backwards to this point. So it's still positive 4, but I rotated negative 135. So I rotated backwards to the point. And then I have one more negative 4. It's just the other way to rotate to this side. It's that big pink number. Okay, that's going to be 45. What can we say? Anything we can say differently? Okay, again, I don't want you to panic if you're like, I'm not sure I'm getting it. Sometimes you sit down with your homework and you can relax a little bit. Before I give you that, though, I'm actually going to give you the homework on a piece of paper today. But before I do that, I want to do one more thing with you. It might actually be a little easier than this, and it is to have a quick conversation about some polar equations. Okay, now stick with me, but I'm kind of switching things up just a little bit. We're going to talk about some polar equations. Now, most of this chapter is a discussion on polar equations. So the ones I'm doing with you right now are just to get us started, and they're actually simple equations. And sometimes the thing that is hardest about these is students don't realize that that's an equation because it's just so simple looking. But it's the equation r equals 3. What does r equal 3 mean? What does r equal 3 mean? Sometimes it's nice when things are what they appear to be. It literally means that the radius is equal to 3. Where is the radius going to equal 3? Well, doesn't it equal 3 right there? Doesn't it equal 3 right there? But wait a minute. The radius equals 3 there, here, there. Do you see what kind of graph we're starting to create? Remember, equations are graphs. What I mean by that is they're lines. But the line that I'm creating is a circular line. In fact, it's a circle. Okay, so the dots that I put on this line, technically would be everywhere. Because what I'm really graphing is a circle. And, of course, it has a radius of 3. Again, almost redundant, but it's a circle that has a radius of 3. One more simple equation. Theta equals 60. Theta equals 60. Now, just from past, I know that sometimes the thing that confuses kids here is, first of all, they just don't realize this is an equation. It's just so simple. But if it's an equation, it's a graph. What kind of graph? Well, a graph where theta equals 60. You mean like this point right here? Yeah, this point right here, theta equals 60. This point right here, yeah, and this one, and every point along a line where theta equals 60. Now, that blue line that I drew right there is clearly an angle of 60 degrees. But the thing that's a little interesting is that technically so is this. What do I mean, so is this? Well, technically, I'm just on the opposite side of the line. But if I'm on the opposite side of the line, it can still be referred to as 60 degrees. It would just have a negative radius. So what I'm trying to say is it's always both sides. Both sides refer to a line that has an angle of 60 degrees. Again, a little redundant, but the equation is kind of telling you what the line looks like. Now, do we have a treat for you? When you guys come back tomorrow, you will see some really interesting graphs. They're going to be much more interesting than just a circle and a line. But that'll be for tomorrow. Now, I'm giving you the homework helper on a piece of paper because of what's on the back of the paper. Will you take a look at the back? Instead of giving this to you on a computer screen, I wanted you to have access to the back of this paper. Just because I stopped counting them. Just look at the back with me, and then I'll collect all those extras. It's some polar planes. Not that kind of plane. Okay, so you can have like a polar piece of graph paper. And I want you to get comfortable with these. Sometimes kids are like, I don't want to use that. I actually want you to use it. And all you got to do is spend a few minutes thinking about the angles on it. Okay, the angles are labeled. Or for the one where it's not labeled, you can do a little bit of simple counting. And instead of me telling you, I just want you to study it a little bit. Okay, do some of your homework using the graph paper on the back. Okay, no, I didn't give you 8. I didn't give you 8 pieces of graph paper, so you might have to share for some of the problems.